Hi students, my name is Reshma Bulani and I have teaching experience for more than 15 years. Now today I will be discussing the chapter real numbers for 10th CBSE. Okay, now in standard 9th I am sure we have studied about real numbers. You must be familiar with the word real numbers. You know that real numbers are divided into rational and irrational numbers. But in this chapter we will be discussing further what is meant. We will be discussing further about real numbers. I will be discussing two important theorems in this chapter, that is Euclid's division lemma or Euclid's division algorithm and fundamental theorem of arithmetic. Before I start discussing this theorem, let me make your concept clear as to what is meant by Euclid's division algorithm or Euclid's division lemma. Let's see. Lemma means, a lemma is a proven statement used for proving another statement. Algorithm means a series of well-defined steps which gives us a procedure for solving the steps. It's in a simple language. It is a proven statement used for proving another statement, and it's a series of well-defined steps, and this steps gives us a procedure for solving the steps. Now what does Euclid's division states? That for any two positive integers a and b, we can find two unique whole numbers q and r, where q is a quotient and r is a remainder, such that a is equal to bq plus r. I further explain it to you. A is equal to bq plus r means a is a dividend, b is divisor, q is quotient and r is remainder. In other words, dividend is equal to divisor into quotient plus remainder. Now I will solve this sum with the help of the example so your concept becomes more clear. Suppose we divide 117 by 14. Now we divide 117 by 14. 14 times 8 is 112, which is 5. Now what is the dividend here? Dividend is 117, divisor is 14, quotient is 8, remainder is 5. So dividend is equal to divisor into quotient plus remainder. Hi students, my name is Reshma Bulani and I have teaching experience for more than 15 years. Now we will be discussing some sums and I'll be helping you solve different type of sums with steps. Let's see the first type of sum. Using Euclid's division algorithm to find HCF of 135 and 225. How do we do? Step 1. Let the greater number be A and the smaller number be B. So 225 is equal to A and 135 is equal to B. You can see that 225 is more than 135. Step 2. So we divide 225 by 135. 135 times is 135, we get 90. Now by Euclid's division lemma, 225, that is dividend, is equal to divisor into quotient. I can write quotient here or I can write quotient here. I'll write it here, it becomes simpler. So dividend, that is 225, is equal to divisor, that is 135 into quotient plus remainder. Now step 3. As you can see, the remainder is not equal to 0. So till we don't get the remainder as 0, we have to proceed this with the same steps. Let's see how. Remainder 90 is not equal to 0. So the new dividend will be 135 now and the new divisor will be 90. So again apply Euclid's division lemma. What is the new dividend? 135 you can see, and divisor is 90. Again 90 times 1 is 95, which is 45. So dividend is equal to divisor into quotient plus remainder. Again you can see the remainder 45 is not equal to 0, that is step 4. So again new dividend will be 90 and the new divisor will be 45. Apply Euclid's division lemma. 90 divided by 45. 45 times 2 is 90. Dividend, that is 90, is equal to divisor into quotient plus remainder. Now you can see the remainder is 0 and the divisor is 45. So the HCF of 135 and 225 is 45. We have to proceed with the same steps till we get the remainder as 0. If we don't get a remainder as 0, we have to continue further, as I told you, till we get the remainder as 0. So this is the way we solve the sum to find the HCF of 135 and 225 by using Euclid's division algorithm.